Hello, my name is Fred Pinkett. Thank you for joining the webinar today. We're going to be talking about three specific cloud application vulnerabilities in authentication and access control. My name is Fred Pinkett. I'm Senior Director of Product Management for Security Innovation. Joining me today will be Brandon Cooper, who's a solution engineer. I'm going to talk at a high level about the specific vulnerabilities, and then Brandon's going to get into a very practical demonstration of what the effects of these real-world vulnerabilities can be. So the vulnerabilities we're going to talk about today are improper identity and access management utilization, the failure to use multi-factor authentication, and improper secret or sensitive information storage. So let's get into the first one, identity and access management utilization. The thing to think about in doing IAM in the cloud is that it's harder than you think. It's very easy in cloud scenarios to get broadly scoped permissions and have overprivileged users and services. Really take time to get familiar with the identity and access management in your cloud service provider. Make sure you avoid any kind of wildcard access. Reduce the scope of permissions to specific business cases. This is really important. When you're putting together your permission setup, make sure that you're really thinking about the need. And when you have cross-account access configurations, scope that to the specific use cases as well. Make sure that anybody who has multiple key pairs you have a good reason for that, and that your keys are rotated on a regular basis so that they don't get stale and easy to compromise. Now, your CSP is going to offer a lot of turnkey identity and access management solutions, but you have to configure them correctly. So you have to be doing things like making sure all important accounts have MFA or multi-factor authentication, which we're going to talk about next. Make sure your identification is set up securely. And then once people are identified securely, make sure your access management is set up properly for your environment. So really, the IAM, you need to think about that carefully, and Brandon is going to show you why. Now let's get into the failure to use multi-factor authentication. Multi-factor authentication, of course, is something you know, have, or are. So the idea being you use multiples of these factors to make it a much more secure authentication. So commonly, it's going to be a password or something plus something you have, like a token or your cell phone, for example, or it might be a biometric or a behavior. So it would be this would be a password plus, for example, scanning your fingerprint. The reason why this is so important and why using multi-factor authentication is so key is that credential stuffing, even in cloud cases, even with, 3 tries and you're out kind of stuff, is still a real problem. And as we move applications into the cloud and we build microservices architectures where everything is accessed via an API, those hackers can leverage those APIs to hijack an account. So you can do a brute force attack with a botnet by using the leaked username and password combinations that are found all over the internet, all over the dark web. So it's really easy in these situations for attackers to take the credentials, stuff them through a botnet, use that botnet to call a bunch of APIs to finally get a valid account to be able to get in. So some of the ways you defend against that is you set rate limiting for your authentication attempts, so it takes a lot longer for these authentication attempts and credential stuffing attacks to occur. But really, you should be practicing zero trust. Don't trust any input into an API that hasn't been subject to a multi-factor authentication. Finally, I'm going to talk a little bit about improper sensitive information storage. Now, when you have an environment in the cloud, people think that, well, okay, the cloud is secure. I've put my data in the cloud, so my security responsibility is ends. Well, people don't really think that anymore, but it's a good reminder that actually cloud data security is a combination of the infrastructure security provided by your cloud vendor, plus your responsibility to set up your access control right, to encrypt sensitive data, to make sure that you're only setting up the data that you need for the application that you need and setting your scopes correctly. Compliance and policy can be aided by what the cloud provides, and they have SOC 2 and they have all these different compliance things, but it's still that shared responsibility. You're still going to have encryption requirements that you're responsible for to be compliant with regulations, and you have to think about the storage location. So there might be jurisdiction implications. Certain data shouldn't be able to be stored in certain places, for example, or in country or out of country or that sort of thing. So think about to think about encryption, you have to think about key management. You may be using the cloud service providers built-in encryption, or maybe you're using your own encryption and encrypting the data before it gets to the cloud. But the key thing to think about, no pun intended, is don't store your lock and key together. So if you have the data and you've encrypted it, make sure that that encryption key is somewhere else and not easily accessible and protected properly. Centralize your key management infrastructure so that when you're doing encryption, you haven't, one, it's much more manageable, but two, you've thought through who should have access to what keys and how that should be managed. Never, ever hard code encryption keys into software or storing those encryption keys in a file for a program to access, because that's just asking for a hacker to find and compromise those. Carefully plan your file system permissions, so where those keys are stored, they have the proper permissions on them. Definitely store encryption keys outside of web content directories so your web application doesn't accidentally serve them up. Build your applications to support periodic key changes as well, and establish a regular schedule for key rotations. And finally, don't include your encryption keys in backups. This is a common mistake. The backup data is accessible, the encryption key is accessible, so you can get access to everything and decrypt it that way. Store your encryption keys someplace separate from the backup so that you can decrypt the data in the case you need to restore that data, but don't include it right in the backup. So let's talk a little bit about how security innovation can actually help you in these scenarios. We can help by doing assessments. We can help look at your configuration, do penetration tests, do attack simulations, so you can see how you're dealing with these vulnerabilities and others. We can train you, where we provide software security focused computer-based training, which is online and role-based and addresses all the different cloud services. And finally, we have cyber ranges, which are based in AWS infrastructure, provide automated scoring and allow you to pinpoint the skill gaps that your practitioners might have, whether we're talking about the engineers or the people who are managing the clouds from the ops perspective, so that you can understand where you need help. There's a URL here you can use to get lots of good free content, or if you need to contact us. So now this is a good time, and especially talking about that cyber range, to pass it over to Brandon, and he's going to show you these vulnerabilities and show the practical implications of those. Thank you for taking your time, and Brandon, off to you.
Perfect. Thanks, Fred. I'll take it from here. Hello, everyone. My name's Brandon Cooper, and I'm a solutions engineer here at Security Innovation. Over the next couple minutes, we'll be taking you through what these 3 vulnerabilities that Fred discussed look like within our command and control Infinicrate cyber range. Now, to expand on how we can help, Command and Control is a platform that we've created that encapsulates these purposely vulnerable applications in an environment that provides gamification, scoring, a hint system, really all the tools needed to make it a fun and engaging event that's going to show learners how an attacker will go after vulnerable systems and infrastructure. Now, our latest 2 ranges focus on the cloud, and in AWS, we've replicated a realistic and holistic organization that shows how an application and its supporting infrastructure can be vulnerable not only to business and software logic flaws, but also to cloud misconfigurations in the supporting infrastructure itself. I'm going to be focusing on Infinicrate, which is our advanced AWS cloud range, and this replicates a cloud storage provider in a cloud native AWS deployment. So you can think of this as a application created by a developer who had AWS in mind from the get-go. So they're using AWS native services like Lambda, in addition to EC2 and IAM roles as well. We also have a more beginner range called Proficient, and that's really great for, again, showing learners how an attacker is going to go after kind of the exterior edge of an organization and all of the supporting AWS services. Now, for Infinicrate, the way we present this to learners is actually through this crowd control bug bounty program that we've created. So learners will go through and interact with these 4 different hacker generals who provide them tips, tricks, and missions to solve within the command and control and Infinicrate range itself. So you'll see here, it tells us what we should be looking for. We're rewarded with points every time we solve one of these. And there's also a built-in hint and support system if learners need a little bit more information or kind of a nudge in the right direction. But then switching over, this is the actual Infinicrate web application itself. And just like all the other command and control ranges, it's a fully functioning web application. So this being a file transfer and storage solution, we can upload files, we can organize those files. There's a way to share those files publicly in a secure manner. And you'll also see us supporting blog and web administrative console as well. And again, with all command and control ranges, really on every one of these pages and each of these features, you're going to find business logic and other flaws for learners to find, discover, and we always try and make it a lighthearted and engaging event. So there's going to be Easter eggs and other great information to find throughout. Now, one thing I'm going to start off with is looking at improper secrets storage and storage of customer data as well. As you can imagine, for an organization who's securely storing and transferring files, one of the worst case scenarios for customer trust would be letting an attacker get access to files which shouldn't be publicly available. And anytime we talk about cloud storage, whether it's S3 or any other provider, one of the common things you're going to hear is security of the metadata is almost just important as security of the file itself. So looking at this application, I'm just going to copy a link to one of these public files, and we'll just start walking through and see what we can find. So if we look at the URL itself, you can see it's making this call, and it looks pretty easy to read. So we'll just start by deleting the file name itself and see if there's anything under this kind of one bucket here, which there isn't. So we'll just keep walking through until we find something interesting. And it doesn't take very long. As you can see, we can actually see the metadata of the bucket that all of these files are being stored in. And not only does it actually give us a link to those files, but we can see whether the files themselves are public or private. And of course, as an attacker, I always want to take a look at some of the most valuable information. So I might start by just taking a look at this secrets.txt file. And spoiler, it actually leads learners to the information that they're going to need to get their foot in the door. We can download it directly, and you'll actually see within is an AWS access key and access information we'll use to pivot to the next vulnerability I'm going to demonstrate. But one other thing I did want to highlight is it's more than just looking for, files and what's being hosted here. The applications themselves and, the information that Infinicrate is making available can be just as vulnerable to these style of attacks. So looking at the Infinicrate blog here, doing a little bit of digging, you'll find that it, again, is hosted in a S3, and we can actually manipulate the URL and tack on a S3 identifier here to look at the bucket and how the files themselves are being stored. And again, you've seen these news stories out in the wild about this. You can put a sensitive file that the public shouldn't see just yet. But if sleuths go digging through the metadata and actually find the URL path, and if it's not being secured properly, you could download a press release or sensitive financial data before it actually is exposed to the public, the public or on the wider internet, and then have the attackers use that to their own advantage. So What I'm going to do next is I'm actually going to pivot over and into the Infinicrate EC2 instance that secrets.txt file got us access to. So we're able to SSH into the server, and from here start poking around the internal network and some of the resources that are made internally available to Infinicrate employees. Now, this vulnerability actually aligns with the OWASP Top 10 2021 entry number 8, software and data integrity failures. So this is actually a new entry for this year, and it highlights the issues that can come with adopting a CI/CD process or even just parts or tooling that can be involved. The big lesson with this one is just because you're in the internal network doesn't mean you're supposed to be there. You can't let your guard down just because a system isn't publicly facing. Being on the internal network is not authentication and nevertheless multi-factor authentication. If you think about going to, say, an electronics store, even if you walk into the employees only area, you're going to most likely see that the product itself is behind an additional set of protection, whether it's its own security room or even just a partition dividing it off from the general store. And when we're talking about software, you have to take those same precautions and make sure you're really practicing defense in depth, not only when it comes to the application that you've created, but then all of those supporting services and tools that you use as part of the CI/CD process. What we'll quickly discover is that Infinicrate is using a Git repository to host their production data and also push the builds through their CI/CD pipeline. Now, what you'll also discover is they've helpfully left all forms of authentication disabled on this particular repository, instead assuming that an internal employee who's on this network should have access. So what we'll do as an attacker is actually download the repository and see what code is hosted within. Now, what I'm going to do is take a code here to clone a code commit repository, and then we'll use a little bit of information provided by the hackers themselves to actually successfully check it out. So you can see they've actually discovered the code repository itself and helpfully provide us the name. So what we'll do is put that in, download it, and you'll see in just a couple of seconds, we're able to clone that entire repository that defines the Lambda function within the Infinicrate environment. Now, of course, from here, we'll want to start to take a look at the code itself. But another important thing to note here is we have access to all of the history that's also contained within that Git repository. So not only can we see the current state of the code and maybe some of the issues found within it, but we can also peer back through the history, see what mistakes the developers have made, not only from a functional perspective, but hint, they may have also included some more information than they intended to in some previous commits that they have since removed. Thankfully, that's all documented in Git, so it's rather trivial to peer through history, retrieve those credentials, and then use that to further our missions within this kind of soft underbelly of the Infinicrate environment. Now, finally, the last thing I want to touch on are some of the Iam misconfigurations and tie it back actually to some of that sensitive data exposure that we highlighted earlier within the Infinicrate environment itself. To start, I'm actually going to remove the credentials that we just used to download that AWS repository. Specifically, I want to show you this as it doesn't require any credentials at all to access some of the sensitive information that you're going to see revealed through some of these commands. Now, some may not think of the IAM policies themselves as sensitive, but as you'll see if you get hands-on with command and control, these seemingly minute pieces of information allow attackers to build a more complete knowledge of the system and eventually use these small interconnected flaws to wrap it around their finger. Now, what I'm going to start off by doing is listing all of the profiles that are tied to this AWS account. Now, remember, we've removed the AWS credentials I had configured for the AWS command line interface, so we're basically doing this from the perspective of a completely unauthenticated user, besides being on the internal network. So by listing the profiles using the CLI tools, we'll see that there are a lot of different profiles tied to this AWS account. Some may interest more than others, and I'll helpfully provide or hint out that there are some admin roles that we definitely would want to dig into if we were hands-on with this ourselves. What I've helpfully done is I've gone through and I've actually identified the role that's going to interest us the most. So what we'll do is we'll actually take this to the next level and look at the policies that are tied to that particular role. Now we can see that the policy name is actually the same as the role name itself, which makes it easy for us to copy and paste. And we'll see by going just a level deeper, we can actually see that policy document itself. And there we go. We can see the role policy here, including what the user is allowed to do and a lot of the permissions that are tied to the account. Now, the other thing that you'll see here is you can actually see some of the sensitive information that's included within the policy. Now, in this instance, it looks to be a secret code, which we can, of course, provide to the hackers for points. But this also, again, may come in handy as we make our way through the system and get deeper and deeper within Infinicrate. So this really shows how, again, an authenticated user can just canvass the system, just look for information, and use those details to kind of peer underneath the hood of the system and see those assumptions that the developer has made, but also the mistakes they've made both in the cloud configuration and then the Infinicrate environment itself. So again, this command and control cyber range is filled with vulnerabilities like this, not only focusing on Infinicrate itself, but also that AWS environment. And by the end of one of these events, the user has really gotten, complete control over that AWS environment, and they're really able to extract all of the secrets and sensitive information from Infinicrate itself. Okay, if you do manage to get hands-on yourself with command and control, I would always recommend you keep in mind that mindset of an attacker. Be curious, be mischievous, also be slightly devious as you look through these applications and again, take advantage of those misunderstandings and assumptions that the developer has made. That's all I wanted to show today. I hope you had a good time today and walk away with some additional information and understanding of how these cloud configuration vulnerabilities can impact a working application within AWS and what our command and control cyber ranges look like. Thanks.